Okay, so here I am. I'm down in my workshop and I'm doing something with a video that I normally never put up. The skid steer is broken. It's the little jack shaft that holds the center chains. I'll show you what that, this is the part. I'll show you everything that goes into it. But I ended up making all these parts. I got some hardened shaft. I ended up making them all just because they're so expensive. And what I'm setting up to do right now is drill that hole through the center here. You can't see it, but there is. Oh, I got it wrong way. Actually, the hole comes from the grease zerk side, and then it lets out right there. So I'm going to drill that right now. And first off, I'm going to go to manual. I'm just going to put my countersink in there by hand. I'm going to rotate this around. Sorry, the lighting isn't that great. Then I'm going to move it in by hand. I can see that I'm way off center right now. That looks fairly close to me. I can still tell I'm a little bit off center. You can always tell by how the chip is. And here's one other thing. I've watched a lot of machining videos and nobody ever says it. But the plane of this x-axis moves up and down. Just picture it being like a manual, where the manual lathe is like this, flat back and forth. You're always supposed to have your drill bit in line with that, just like you would a boring bar or anything. So you're supposed to have the flats. I hope that everybody understands that. The flats like pointed that way and that way. It just makes the drill bits last a lot longer. So I'm going to put the countersink in here. Now this is hardened on the outside, not the inside isn't hardened. Hope I didn't tighten that down. Let's see if we can get that to stay. I should have tightened that spot drill down. That's enough for my drill bit. Now I'm gonna set the zero. I'd rather drill it here than drill this on the manual, just because it's so much smoother. And this is an Akuma, so now I'm setting up the zero on the Z. And for a drill bit, I'm not too super concerned. I watch for it right here. And let me grab this here. Hold on. God, I'm going to try to make this video not so long. I can see that there's just a tiny bit of a gap there. Right there. So then I'm going to come over to the controls. Hold on. And here's the little program that I'm going to use. I go to tool data. Let me take the guide off. Oh man, which offset am I using? I'm using offset number 3, so I go tool data, go down to offset number 3, and extend that. And for this, I just go calculate 0 right, and that number just changed. Same with the X. Now this, we're just going to do this by eye too. call it right there. Same thing here. We're going to go calculate 0, and that'll bring that number pretty close to 0. Now we're going to walk this back. Come back over here, turn the coolant off right now, go to auto, relook the program over, turn the spindle speed down, turn the feed rate down, put it in the single block. Single block allows me a great deal of manual control on this. So it's only going to read a single line, and I'll be able to control that any movement of the X and the Z with my feed rate, so there will be no rapid movements. So my G50 just designates a top speed. The T203, come on, is the tool number, and then my offset number. The G97 is just a constant speed of the spindle, and I've got that set at 1,000. G0, that's rapid movement, and that brings me down to the X0 and Z of a 0.1 thou, so 100 thou away from the front of the part. G74 is a can cycle. That's my drilling cycle, and it's going to be at X0 and Z of a -3 inch, 3.250, which is 3 1/4. And every time it drills, it's going to drill 50 thousandths. And the L is the lift. It's going to lift out 100 thousandths, and it's going to do it at a feed rate of 0.0035 thou per rev. So it's going to barely take a little chip, but when you start sticking and drilling that deep, you want to make sure. And then back to Z0, G0 brings it out to the 0.1, and then it goes home. It goes this, you can put any number that's got stops, so you can go way beyond what you should be. And then the M30 designates program end. So let's go to autos, and let's start it up. Let's see what happens here. So now it's on the G0. Should bring it right into 100 thou of the part. And you always want to look to make sure that's 100 thou. Like, if you look at the caliper, that's about what 100 thou looks like. And as you can see, the machine is right on the money. So let's press start. Watch our can cycle run. And there it goes feeding. It's feeding right now. Went in 50 thousandths. Now it's coming out back to 0.1. Let me get a chair here. Hold on. Okay, so now I'm back. I'm going to take that single block off, because I know I've been doing this for enough years. I'm going to turn my RPMs up to at least 90%. With that, I can run close to 1,000 RPM on this smaller drill. And I'm just going to press cycle start and let it rock, and you'll see how it moves. And at some point in time, I'm going to turn the coolant on here. And slowly but surely, it will drill that part all the way through. Stop it for a second. Just gonna check it. I'm gonna let it rock. I can come back over here. I'm going to change my feed rate down 50% of what it was. Repress cycle start, let it run. And I can actually go to my actual position. Actual position, page down. And it shows how deep it is. This is actually how deep it's going into the part right now. So right now, it's coming up on 1.5 inches. And I'm listening to that drill bit the whole time to make sure I don't hear nothing funny. Because you gotta remember that drill bit is loading up them chips around them flutes. And they drag. As you can see, she's starting to get in there pretty deep. But as long as I don't over stress the drill bit, it'll go. And already we're at 2 inches. We're going to 3 inches, 3¼ inches. So we got a ways to go. And we don't want to break the drill bit off in there. This is the last piece of steel I got. I'm going to pause it. I got to move my coolant line, so give me a bit, and I'll show you when it's all. Give me a second here. I'm going to read. Okay. So now we got that. Let's watch it go. 2.7. See how deep it's gone right there. 2.9. You can see we're getting pretty deep in there. 3.1. This is going to be the 3.2. I'm sorry, I did say that program wrong. It's actually taking 2 bites, coolant off. And now as you see, we got a hole through the center of that goes down, which we can check it. No, it's not going to go exactly 3¼ because the flute of that drill bit is going to take off about 70 thou about it, but we'll see what we get here. So 3.186 thousandths. So just think about that. That little drill bit just stuffed itself that far. And see, there's no way I could have done that with the manual that nice and easily with that small of a drill bit. So next, I gotta cut this to length, which is a pretty easy task, but I'll show you how this goes on the skid steer quick before I end this video. Alright, there's the skid steer. You see that little thing right there? That's where that shaft is, and I'll show you what that shaft is connected to. Give me 1 second, we'll get over there. So we're back on the manual lathe, and this is what that shaft is connected to. Inside of the skid steer, there's a hydraulic motor. That hydraulic motor drives a little chain, I think it's like a Series 40, drives this bigger sprocket. All these holes is where your lock pins go for when you lift up them arms. They go in there and that keeps it from rolling. And then in turn that power is brought down to these sprockets, which turns that. This is where the bearings go. I had to re-weld this because this got eaten up a little bit when that bearing went out. I put a couple beads of weld there and a couple beads out here just to shrink the whole thing down. And them sprockets in turn, I'll show you what they drive. That goes to the tires. Let me get over there. They drive these sprockets. And as you can see, on the other side is where the wheel bolts up. And these are actually pretty big sprockets compared to my hand. And they go right there. There's where that center jack shaft goes. Sorry about it being dark out here at night. And that's where the rear tire goes. And inside there is chains. Oh, here's the chains. Here's the two different chains. These are the big chains. Wait, this is the small chain and here's the big chain. These are like the heavy duty ones, but that's how the skid steer works. And that's why both tires turn. And it's all turned from a little hydraulic motor that's up underneath your feet on the 1845C. Alright, I'm going to go get this done and I'll try to make another video and show you guys what it all looks like when I'm done.